All right, we're continuing Roman numerals, where we've looked at fairly small numbers. And at that time, the civilization didn't require numbers to be too big. And we'll see that as we look at larger numbers, things become a little less efficient. But we should still look at 5.2, larger numbers. So, at the, let's see here, larger numbers. With the number system we've discussed so far, the largest number we can make so far, the largest quantity, I guess is more accurate, we can represent is, well, we can't have more than 3 in a row, so I guess we can go 3,900, which is going to be what? You have like 3 whole weekend days to CM. 90.
XC.
9. So that would correspond to 3,999. Now, when you calculate area of land and things like that, that's not really that big. It depends on your unit of measurement, of course. So that number is not that big. What do we do for larger numbers? The nice thing that they came up with is instead of using or introducing more and more letters for 10,000, we're working in tens. So we can handle the ones, tens, hundreds, thousands, sort of. Instead of introducing more numbers for 10,000, 100,000, which all the other civilizations have done, just create more and more symbols, more elaborate symbols for these larger quantities, they decided, no, let's stick to these letters, not introduce more letters, but instead, let's sort of recycle them by putting a line over the letters. So if I put a line over a letter, that is going to represent multiplication by 1,000. So let's say here to represent times 1,000. Oops. So, for example, start camera. For example, 5,000 will be represented with a 5 and a line over it. And in that way, I'm not introducing more and more symbols, and it doesn't get overwhelming. We have our letters. They're not going to change. They're not going to increase in number. We just have this little line, and then the number that's represented under the line gets multiplied by 1,000. So it's a very efficient system that other civilizations weren't able to think of. But now, so let's just come up with some random examples before we look back at the book. What if we have 120,000? What would the representation for that be now? CXX with a line. So essentially you're still thinking of ones, which is 0, tens, hundreds, thousands, there are none of those. 10,000s, well, there are, if I look at that on its own, it's 20,000. If I work backwards, so that 20,000 as the representation 20 with a line over it, because it's 20,000. Then the 100,000 going big to small, 100,000 is next, which is 100,000. And then we're just making a nice connected line. If you want to break the lines up, it just gets a little messy. But you can do that as a temporary one and then say, okay, let's make the lines nice and straight and neat to make the representation a little nicer. There's the problem though. If I just stop here and start representing larger and larger numbers, as we mentioned previously, we want just one way to represent a number. As soon as we have a quantity that can be represented in multiple ways, over time things can unravel and communication could sort of fall apart. So if we leave it like this, what would happen if we represent 4,000? There could be multiple ways to represent 4,000 if I just stop here. What's one way to represent 4,000? IV for 4 with a line. That's one way. Actually, sorry, I wanted to go with 6. Sorry. Well, we can do 4 in a second, but 6 is a little easier. That would be VI with a line. But I could also say that it is thinking of 6 as 5 and a 1. I can think of this as 5,000 and 1,000, because 6 here was really 5 plus 1. So that would then mean 5,000 and a 1,000. So that would also be valid. Now, unfortunately, as much research as I have been able to do, there isn't really conclusive evidence to say which one they chose. And if you happen to find something, some proof, not just speculation, that says which one did they actually use, then please let me know. I wasn't really able to find it. So we're just going to have to make our own guess and be consistent once we decide on a rule. Because we can't have multiple ways to represent quantity. And those right now are both valid. So by adding one little rule extra, we can avoid that. And I don't know if that's what they actually did, or if they even considered numbers that big. It's not that big, so they must have had some system, some rule to handle that. I don't know what it is exactly. So let's add one more rule. One more rule. If I can remember the camera. So again, this one is a possible rule they could have added. I don't know for sure. And that is never use an I under a line. Simple as that. You're never going to have an I under a line. So that would then say, no, that is not right, and this is the one we're going to go for. So feel free, if you feel like researching it, let me know. But some parts of history is a little hard to say with 100% certainty what they did. So then we can look at some numbers in the thousands. And I have a table there on the next page, but I'll write some down as well. So then 1,000 would obviously be the M that we have a letter for. 2,000, 3,000. Let's do 3,000. I'm not going to do all of them. I can do 3 in a row, so 3 M's are fine, instead of 3 I's with a line. That is not going to be allowed. So we've made a decision, no I's under a line, which means we consider that as not valid, and that is instead a valid representation. 4,000 is not going to be IV with a line, but instead, okay, that looks a little weird, sorry. Right? That's not going to be valid. Instead, we are adding more of those special subtractive pairs in a sort of natural way by saying it's 1,000 less than 5,000. So we're not really making a list of all those extra subtractive pairs which are now happening in the thousands, because they follow the same way of thinking as they did in the ones. A 4 was 1 less than 5, so a 4,000 is 1,000 less than 5,000. 5,000 we've done, 6,000 we've done. Let's do a 7,000, which will then be 5,000 and 2 1,000s, just like 7 will be 5 and 2 1s. So with that rule, it does make sense because it fits the same pattern as the ones would have done, the units. Does it make sense so far? Okay. Let me squeeze in a little here. 9,000. Thinking of 9, we follow the same pattern with 9,000, which would be 1,000 less than 10,000. It's very quiet. Is it the Monday effect? Okay. That extra day off hurts in a way. Not always a good thing. Taking a Friday off. What else is tricky? Let's do a random one like 12,000. That would be, well, what would 12 be? 10 and 2. So you could have done them separately. Let's do them over here as temporary. I need 10,000, so 10,000. And then 2,000 can be covered with the M's, so that'll be it. So there's no extension of lines that I have to do or anything. So sometimes if I do a temporary one by looking at the digits separately, my lines will be a lot of pieces that I can connect to make pretty. But in this case, there's nothing like that. What other one is maybe worth mentioning? 17,000, for example. Again, here you could do a temporary one, just sort of a side note to figure out. 10,000. 7,000 will be 5,000 and 2,000. So then you can make it look pretty with the X and the V under a single line by just connecting the line. Just making it look a little pretty, because when the numbers are bigger and there's a lot more of these underlines floating around, it's really hard to do them as separate pieces. So one line would be a nice way to look at it. Let's do a 19,000, and then that should prove our point. How this extra rule is really allowing us to extend the pattern in the ones to the thousands. 19,000. Well, I still have my 10,000. So let's do a little scribble on the side to figure it out. 10,000. Now I have to take care of 9,000, so it is still a decimal system that I do each place separately. And then just maybe make it look a little prettier. 9,000, well, what is 9? 9 is 1 less than 10, so 9,000 is going to be 1,000 less than 10,000. So it's going to look like this. Perhaps a little strange. Does it make sense why it looks like that? Following the same pattern as it does in the ones, if it was a 9 only. Any questions, comments, concerns? Maybe some concerns, but with a little practice, not so bad. Of course, the bigger numbers, the number system wasn't really designed with those bigger numbers, larger quantities in mind, so it does sort of make sense that it could be a little less efficient if we have these bigger numbers to represent. Any questions? Comments? All right, now it's just a matter of practice. Practice, practice, practice. Exercise 5.3. Let's start small. Let's start small. And even if that's all we do today, that's perfectly fine. I gave a very easy one first. I apologize. We've already done this one. 5,000, 5,000. V, X, X, V, all with a line over it, will be? How do you get 4? Did you say 40 or 20? I heard 40, I'm sorry. At my age, you know, the hearing is the first thing to go, they say. Yes?
If you put M in front of the two X's, what is that? Is it not, is it
If I put
19,000?
M in front of the two X's,
Or can you not do that?
that,
Like for the others, like for
This
the
one?
19. Yeah, because I'm just thinking if that's 20. I don't know
see,
if
but
that's...
this is now a special pair. A new one,
So that would be...
it's the 1,000 equivalent of 9. So it's a new special pair added to those 6.
So you can't do M.
So you can't do another, you want another X over here.
I want like M in front of the X.
Another M here.
Like one
Oh.
M and then two X's.
If you want something like this, one M and then
Two X.
like that.
Yeah. What is that?
So now you have to think, well, this is a special pair here,
Oh, okay.
which would represent 9,000, which would be in my thousands column. But that guy is then at 10,000, so it's out of place because it has to be here.
Okay.
So the same validity issues are still there,
Okay.
maybe just more hidden. But for the same reason, you couldn't write 9 and then another 10,
Right. Okay.
because the 10s have to go on
That
this
makes
side.
sense. I was
It's the
just
same
wondering
thing.
why.
Yeah. They just look a little stranger, I guess. But the same thing's happening now, just in the thousands.
Okay.
So I still, checking if they're valid becomes a little more tricky, to be fair, because I now added these subtractive pairs without really listing them. But they follow in the same way as the previous 6. What else do we have here? There's a typo in C. It should be CC with a line and then 3 M's. Because the rule says you can't have I's under a line. And then I made a typo right away. So we fixed the typo. So that's what it should be. What does that represent? I'll still go one place at a time. What is this place? The two C's with lines or with a line over it. What place is that representing? It's the 100,000 place, which would make it 200,000. I'll emphasize it there. 200,000 just from that. 200,000. And then 3 M's, which will add, oops, sorry, not there. 3,000. So you can do it separately and say, okay, that's the 200,000 position, or the 100,000 position, there are two of them, plus another 3,000 for the M's, that's the thousands position, and nothing else is coming after that. So I put it all together.
Are you taking the L or 50 out of the?
Did not see the L.
Okay.
Did not see the L. So not only is my hearing going, my vision apparently as well. Everything's falling apart. That is what it should be. Is it Friday yet? Saturday. Just the eyes are making it invalid. Is everyone happy with that one? All right. Okay, so I'm still doing the same thing now. These two C's make the 100,000 position, or column, or whatever you want to think. So it's going to be 200,000. Let's do it in detail then. That is going to be 50,000, and that's going to be 3,000. Not that you have to write it like that. You can put them all in one, but just to emphasize where all the digits are coming from. Some people are happy outside. Once you get the hang of it, it's really not that bad. Any questions on that? So it is still a decimal value. Think of the places, they're just bigger numbers. Then we want to go the other way, which is arguably more difficult now. If I had to choose between the two back and forth conversions, which one is more difficult? Maybe the other one. Given a decimal number, how do I write the Roman equivalent? So what's our first example there?
582,000.
Yes, please make sure that I'm writing down the right thing. This was number 1. This is now number 2A. 582,000. 582,000. All I want to do is just practice this. So take a few seconds, think about it. How do you feel about it? How easy is it for you? And that tells you how much you need to do in terms of practice. The additional examples may not be sufficient for you. I didn't want just lists and lists of numbers. You can easily make your own or challenge a friend, make up random numbers. The Roman number equivalent for 582,000. We're starting easy. And I really just have to think of 582 and then put a line over it. So that's not so bad. 582 is? She didn't fall. It's not a full 582 because the 2,000 has 2 M's and not a line. That's really the only catch there. It's not the full 582. Then I'll have 2 I's there. Can't have a line over any I's. So the 2,000, the 1,000 position needs to be treated with a little more care. We're happy with that? It's okay if you're not happy. It's Monday. The mood is not as happy as I want it to be. What can I do?
I have a question.
Yeah.
For the 5.3 at the C above it,
Oh yeah,
we
we
could
fixed
do
it, right?
2 I's and 3 I's under a line, but now we can't.
No, 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 it was a typo. I made a typo.
Oh, okay, thanks.
That's not valid. It's not valid. No, no, no. Never any I's under any lines.
Okay.
There will be more typos coming,
Oh, okay, cool.
but there are typos. Honestly, I typed it, then looked up, well, what do they do between those two? Then I settled on the I, no I under a line rule, and I didn't look back to fix my examples. To sum up, I fail as a textbook writer. 53,000. Oh, that's an easy one. Isn't it easy? The easy ones make me feel totally fine. And predictable. The test is going to have convert this back and forth. Very predictable questions, which makes it easy. I just have to look at them separately. 50,000, piece of cake. 3,000, I can do those with M's, and I'm done. Isn't that easy? I think it's easy. You feel it's too much writing down, not enough hands-on playing with things. You want to play with Play-Doh, I sense it. On Wednesday we can play with some Play-Doh. Balance out all the numbers. How's that? And maybe if all goes well, I'll have some guest appearances because they want to play with Play-Doh. So maybe we'll see. Usually they're all talk, ooh yeah, I want to come for Play-Doh Day. Then they show up, see all the people, and run away. Don't ever get your hopes up. That's usually how it goes. But they heard we're playing Play-Doh, so they should come. 168,000. So right now what I'm seeing here is take care of the thousands position, a little more than the others. That's what I'm seeing. A little bit. But I can still do them one at a time. Now 100,000 is that guy. So that'll be a C with a line. Well, let's do them temporarily. C with a line, 100,000. 60,000. 60,000. I can just do 60 with a line over it. And 8,000. Well, 8 is 5 and 3 ones, so this would be 5,003 single thousands. And then you can make it look pretty by extending that line. So CLXV is under the line, and then 3 M's. Not that you have to do this in between step. You can do it all in one go. It's totally up to you. Even if you leave it like that, I won't mark it as wrong, but sometimes it can be a little tricky to see what's under your lines and what doesn't have a line and so on. So it's nice to have it extended or connected. We're happy with that. All right, where are we now? Okay, so the nice thing with this line notation is that the sky's the limit, really. Because I can now make a number that has a line and put another line over it to make multiple multiplications of 1,000. Like exercise 5.4, 1A will be V with 2 lines over it. So you just work from the inside out. So it'll be 5,000 multiplied by 1,000. So 5,000,000, which will be the representation for 5 million. So the line over notation is actually very efficient in that the larger numbers don't really have representations that are longer necessarily, because I just multiply by 1,000 again and again. So that's very efficient. Then we have something like B, which is practicing this multiple line setup. V with a line, then 2 X's, and all of them get a line. So lines inside lines. Just had to take it too far. Sorry. We can handle it. Work from the bottom outwards, or inside out. So do this first. What is that? What is that? 5,020? 1,000. So it will be 5, 0, 2 zeros, and then 3 zeros. So 5,020,000. Does that make sense?
This one's got an I with a line over it, I think.
Yes.
It should be a
Typos. I'm happy that there are only 2 typos, honestly. That's a win for me. It should be X with 2 lines, L, and then 3 I's. I connect my I's because I think it looks nice. That does not mean it has a line over it. But typed is no issue. So hopefully that doesn't create any issues. There's no line over the I there. Right? Okay, what do we do with this? This one's pretty easy, isn't it? You just do one of them first. So this will be 10. First line makes it 10,000. Another line makes it 10 million. And then I just take care of these ones. 53. Oh, it's not bad. How many zeros do I have here? 1, 2, 3, 4, 5. 10,053,000. Is that right?
Is it not VLIII?
No, I'm changing it.
You're changing, okay, make sure you change it.
Changing the question.
How would you write 4 million in Roman numerals?
4 million. Can we write this space here? What do we think? Because we can't have an I under a line. So what is it not? What is the temptation? It's certainly not 4 with 2 lines. Because then an I is underlined, and that's not allowed. So what else should we do?
The N or MV would be 2 less.
So look at the 1,000 first. Look at this. And then to make it another, to add those extra 3 zeros, we'll put a line over it. So what is the representation for 4,000? That is 1,000 less than 5,000. And for those 3 zeros will be another line. So you're not making 1 million less than 5 million. What would that even look like? No, that would get very confusing. Yeah. So my subtractive pairs are only going into the thousands. And then I can put more lines over it if it's further into the number, so to speak. So the side one here, that should probably be added. A good observation. Any other questions? Yeah. So what that C is trying to represent is 4,053,000. So instead, it should have been, if we change this to a 53 and want to represent that quantity, you have your 4 million here and then 53. Maybe I should have changed it to that, that would have been better. Any other questions, comments? Need time to get used to it, so I don't want to rush it. And then you're forced to sit on your own and figure it out and struggle, and that struggle makes me very negative sometimes when you feel isolated and struggle on your own. Yes?
For that, with the line
be like 5 million minus 1,000? No. 5 million minus 1 million? Since there's
5
only a
million. You're essentially saying 5 million minus 1 million. And then the lines are just a little strange there. So to not have any more subtractive pairs, these are essentially the same.
Okay, I see.
The top lines are connected, and the bottom one. This bottom one is 1,000 compared with that 1,000. So it is the same.
Does it matter which order you put the lines in?
Yeah, that's what I was wondering. Like if you add the second line on top.
If you, let me just turn it so everyone knows what I'm talking about. If you're saying this,
Yeah.
Yeah.
would that make sense? Because then what's happening under, you're working inside out, right? What's that? Let me just, yeah, that's, you're saying this. What is happening under here? Does that make any sense?
So there's a specific order you have to do it in?
You can't have a small line over something. This is, as soon as you have a line, it connects them. So this is one thing that has to be represented first. Now that multiplies by 1,000, but what is multiplied? Because this is one thing. You're not isolating the 5 anymore if you're connecting that line. Now it's 1,005. That big line makes it 1,000. Where does that little line apply? See,
So
it
it
doesn't
depends where you
work.
put them to.
So if you're going to go lines on top of lines, it'll be the same length or longer as you go up. Because if you have a short line over a long line, where does that short line, what does it multiply 1,000 by?
You read it upwards then?
You read it from the inside up, yes. Yes. Yeah, it wouldn't make any sense. Good question, yeah. But if you have it like this, where the inside, the first line is this length, is 1, and then the next one up is longer, now you know it applies to this. And you can multiply that by 1,000. Other way around, you don't know what it applies to.
So you represent the subtractive pair first, and then.
Subtractive pair, and if I'm this deep in, I'm going to use the thousands. So in this case, I see it as 4,000, because I can't see it as 4. And 4 million would have been a little confusing, though essentially the same. So by looking at it in the thousands, using those subtractive pairs, it's really sufficient to do anything. I'll just put more lines over it if it happens to be in the millions or whatever comes later. So my subtractive pairs don't continue forever. They only need to go into the thousands. All right, let's try the other direction. Very easy. More questions, sorry. Oh. 2A is 582 million. Just linking with my other example. 582 million. Now I'm going to look at it the same way as the other one, and then I'm just going to put a line over everything for those last 3 zeros. So it's going to be, so now I look at this first, 582,000, because I know I'll eventually just put a line over it. Which means I look at this 58,000 first, that was 58, no, 500,000, sorry. 500,000, D. 80,000. So I'll eventually put a line over it. I'll put a temporary line over that one. I'm just doing the circle first. 500,000. 80,000. 80,000. And the 2,000 doesn't get a line. So now I can connect these, make it look as nice as possible. That was the circle. To get these, to put it in the right position, I'm multiplying by 1,000. There's a subtle practice of our decimal system happening here, which is the multiplying by 1,000, moving the number and attaching zeros and all those things that we might look at these Roman numerals, but we're actually working in our decimal system. It's just a little hidden. Everyone okay with that? All right. 7,053,000. The only way through this is just practice, practice, practice. 7,053,000. So what am I going to do? I'm going to look at this first, because I know those extra 3 zeros will just be multiplying by 1,000. Take the circle, multiply it by 1,000, and then I'll be done. So look at the circle first. 7,000. That's 5,000 and 2,000. 53. 50. Did we do this one already? It looks so familiar. So that's 7,053 multiplied by 1,000. Oh, sorry. Okay, fine. That was our first attempt. First attempt. Now we just have to fix it a little bit, right? You see this, where's the problem? The problem is I just needed to keep the 3,000 separate, which we can easily do and just update. There's no problem. As long as that's not our final answer, it could be our temporary answer. As we're working towards the answer, that's fine. How's that? Manageable?
I'm bad at this.
Same.
It takes some getting used to. And I think we can honestly, for testing purposes, leave out exercise 5.5. Because this is already, you can do it for fun and check your answers, but I think this is enough. Unless you say, no, this is too easy, add a step. But I think it's good. Look at those, they're just for fun. So this is the level a test would be, or smaller, of course. Maybe that makes you feel better, brings some smiles. It's my job, I want everyone to be happy. One more. 168,023,000. You could argue that, the Romans didn't have issues with numbers that big. Why don't we just stop there? We get the point. We got out of it what we needed. And perhaps you're right. And it is there, the last exercise, if you really want to look at it, but it's not a test question. All right, so I know the extra 3 zeros won't be a problem at the end, so I just have to focus on this as if it's 168,023. So 100,000, I'm just doing a temporary building of the number, and then I'll clean it up if it needs it. 60,000. 8,000. And now I can connect these. Maybe don't make all a wobbly line, maybe erase it and make a nice line. So that's 168,000. Then the 23. So this is just temporary, right? Oops, 20. Just temporary for now. And to get those 3 zeros, I would multiply by 1,000. But now I see, uh-oh, I need to fix this. Because it's 3,000 that needs to just be separate. Sorry, finger erasing is not looking very good. So I'll do them separately as 3m's. I can have it temporarily, just not my final answer. Yeah, I think that's good enough. Let's not push it too far, but like I said, you can totally do those for fun if you want to, on exercise 5.5. But I think maybe that's as far as we need to go. And there's some hidden decimal number practice here, that even though we're working with Roman numbers, multiplying by 1,000, moving something around, putting zeros, it's what we do in whatever grade, early grades, multiplying by 1,000, multiplying by 10, moving things around. So it is very closely linked to our decimal system. By looking at the Roman numbers instead, we're just a little bit out of our comfort zone, and we're forced to really think about, in this case, multiplying by 1,000. Think about looking at the digits separately and what position they're in. Because we're so used to the decimal numbers, we don't even think about it. But as a little kid, it's brand new to them, they really have to think about it. So that's one benefit of looking at these number systems. They are closely linked to our decimal system, but it's not that comfortable, so we really have to look a little bit more carefully. Right, this is the insert for exercise 5.5, where we convert larger numbers from Roman and to Roman. 1a has a large number that I'll copy down. 3 x's and a v under a line, then 3 m's, a d, an x, an l, v, and an I. Let's just make sure that's right, otherwise it'll be very silly. And we have to convert that to a decimal number. Okay. Well, remember that it is a decimal system at heart, really. So let's isolate the ones will be there. Where are the tens? The tens are here. That is a special pair. Then the hundreds. That's a 500. Then I have to double check here. Where are the thousands? Where are the thousands? Not just the m's, but the 5,000 as well, and that'll give me an 8,000. And then these are the 10,000s. So I have, let's do it like this, 30,000. Here I have 8,000. Here I have 500. Here I have 40. And here I have 6. So therefore, the number is 38,546, because I just add them together. B, copy that down correctly, DCL, 3 x's and a v, and all of that under a line, MCDI, MCDI. Okay, again, isolate the decimal places. I have a 1. I don't have any tens, so I'll have to remember that. I have a CD, that's the hundreds. Where are the thousands? Right there, 5,000 and a 1,000. Then I have 30,000 here,
but this is also in the 10,000s, and then my 100,000. So this is going to be 600,000. This section is 80,000. This is 5,000 and another 1,000, giving me 6,000. That is 400, and that is a 1, giving me 686,401. One more of these conversions. Let's write that down. M and 3 C's. M and 3 C's. LXX. And all of that under a line. Then I have an M and a V under a line. D, X, I, X. All right, let's section it off. I have my 9 here. I have a single 10 for the tens column. Then I have my hundreds, my thousands, a special pair. 10,000s are over there. 100,000s are over there, and my 1 million. So here I have 1 million. Here I have 300,000. Here I have 70,000. Here I have 1,000 less than 5,000, which is 4,000. Let's do it like this. I have 500. I have a 10. I have a 9. Therefore, it is 1,374,519. Now we do number 2, where I convert the other way. Let's write down the number 86,473. Now think of it this way. Break it up. It's obviously, let's do it like this. 80,000, 6,000, 470, and 3. So now I simply start converting. 80,000, well, 80 is LXXX with a line over it. 6,000 will be 5,000 and 1,000, and I can connect those lines to make it look pretty. 400 is 100 less than 500. 70 is LXX, and 3. Don't be confused by that. I just do it like that because it looks nice. It's not an actual line over it. I'm just connecting the eyes because it's like a font. It's just nice. But you don't have to do that. Next number, 864,731. So it's 800,000, 60,000, 4,000, 700, 30, and 1. So 800,000. So 800 is what? That's DCCC, 1,000. 60,000, what is 60? 60 is LX. And I continue my line. 4,000 is a special pair. It's 1,000 less than 5,000. 700 is DCC. 30 is 3 X's and a 1. Done. C. 6,638,457. All right. I'm just gonna maybe move this down in case I run out of space. I'll do it over here. I have 6,600,000, 30,000, 8,000, 457. So 6 million. What is 6 million? Remember that you can't have an I under a line. So I have to do 6,000 times 1,000. What is 6,000? It's 5,000 and 1,000 times another 1,000. That's 6 million. 600,000 will be 600 is DC 1,000. Now, if you don't like the lines, I'm not going to be too uptight about how you connect the lines. Perhaps on the spot here, I'm thinking maybe it's better to keep them separate if you want to. If you really want to, it doesn't matter if you keep them separate. Let me just make it clear here what's erased. Hopefully that's clear enough. I think so. So now I have 600,000, 30,000, so that's 30,000. Just to show you don't have to connect them if you don't want to. 8,000, that is 5,000 and 3,000. 400 is a CD. 50 is a single L and a 7. So it's up to you if you want to connect them or not. At the very least, if you're not sure, you can maybe connect these or leave them completely. It really doesn't matter. I'll accept them all. If you're not sure, you can leave the lines as separate pieces. It's all good.